Hello, Chris Brown from Conservation Hackers here. At Conservation Hackers, we're helping to train people in quantitative computer programming skills to help nature. So tonight I want to talk about the important issue of why you should always plot your data and why you should do that before you do statistical tests. So people often come to me with results of statistical tests, but no plots of the data. And that's a really silly thing to do because you could be missing some really interesting patterns in the data, or you could be using totally the wrong statistical test and not even realize it. So tonight I'm going to give you a quick demo of why that's important to plot your data before you do statistical tests. And I'll give you an example of how it could go wrong if you don't do that. So let's flick over to RStudio and we'll get started. So here we are in RStudio, and I've just set up a little bit of a script. We're going to use the ggplot2 package for plotting, and this bit of code here just makes up some data for use in the example tonight. So the data is pretty contrived, but I'd say not as contrived as some of Trump's claims about this election we're currently enduring. So we've created two groups of data, y1, y2. Let's just pretend that they're two time series of some variables collected at the same time, but two different variables. And then I'll just stuck them together in a data frame. So one way we can look at this data as a statistical test would be to use a t-test to compare the two time series. And this is something that students that are just starting out might often do because it's one of the simplest tests you can do. So in R, I've just typed t.test, and I just put in the two time series, y1 and y2. I run that, it prints out a nice table here, and we can see it's telling us a p-value of 0.3. So first of all, this is an odd test to do on time series because we're just comparing the two time series to ask if their means are different. And it's saying p.03, 0.3, so we'd typically say that's no significant difference. But there could be other things, other patterns going on in the time series other than just the differences in means. So a better way to look at that would be to plot it first. So on this line here, I put the time series together into a single data frame, which will just allow us to plot it easily in ggplot. So I'll just give you a look at that data frame before we plot that. So it just has one column X, which is the time, column Y, which is our variable, and then another column labeling whether that variable is Y1 or Y2. So this is called long format data because instead of having one column for Y1 and one column for Y2, we just have one longer column of Y values and then a group column labeling whether it's Y1 or Y2. So in ggplot, you can watch some of the early tutorials to learn more about ggplot. I'm going to use my snippet just to quickly autofill that ggplot code. I enter in the data frame first, so ggplot.dat, so it knows which data frame to look in. Conveniently, we've called the value we want on the x-axis x, so leave that as it is. Value on the y-axis y, leave that as it is. And our geom will do points. And I'll just color the points by group, so y1 and y2. Now drag the plot window bigger, run that bit of code, and I've got an error. I just put points instead of point. Common mistake. Sorry, so geom point. And there we see our data. So there's clearly something going on here, more than that test showed us where it said it was no significant difference. You can see that y1 and y2 have mirror image patterns. Like I said, pretty contrived data. And we could get a little bit more elaborate with our ggplot if we wanted to see a trend line through those two curves if it wasn't obvious enough. So I can use stat smooth. And there you go. You see there's clearly a difference, whereas in the t-test there was no significant difference. So that's all for tonight. And that is why you should always plot your data before you run statistical tests. Thank you.